Hey everyone! So this week we're going to be talking about induction. Sorry if you can hear my rabbit sneezing. She's a little under the weather. Okay, so today we're going to be talking about induction this week. And I'm going to tell you to buckle up, not because it's going to be a fast ride, but it may be a very bumpy ride. In the past, I have seen students struggle the most with this. And that doesn't mean to scare you, but just pay attention. Let's see, you can rewatch these videos and things, all kinds of options for you. How would you prove that you can climb an infinite ladder? Okay, so I was taught this by another professor, and I think that it's genius. So think about to yourself, and like, you have infinite time, infinite energy, whatever for that. But how would you be able to prove to somebody that you could climb it? Okay, maybe you're proving it to me and I only have a finite life, but maybe you have an infinite life or something. How would you prove that to me that you could actually climb this ladder forever and ever and ever and ever and ever? Whereas I can't just watch you do it forever and ever because someday I'm going to die, right? Or something. I don't know. Sorry, that's a little morbid. But so this is the part where I have the students start writing down some ideas, and then we bounce ideas off of each other and stuff. So I strongly suggest you just try it. You don't have to take like 20 minutes to try it, but just jot some things down, see what do you think you would need to show me to show that you could prove to show me that you could climb this thing. So this is your chance to pause. The first thing that I think a lot of people miss is, can you even get to the ladder? All right. So like, what if there's a river and you can't swim, or it's an infinite river, or something like, I don't know. So you need to show that you can even get to the first rung of that ladder, that you can even get to that ladder and put your foot on it. Okay. So then, okay, I'm on the first rung now. How do I show Danica that I can just keep going and going and going? Well, you could show me that you could get to the second one. And then for the second one, you could get to the third one. And then you're like, but this is the trap that I fell in before, because Danica's life is finite, whereas mine's infinite in this story. So I can't just keep doing this forever and ever. But what if I just picked some random rung on the ladder? Say the kth rung. So maybe you're helicoptered in or something. I don't know. So you're helicoptered in and you're on the kth rung. Can you show me you can get to the k plus first rung? Okay. So this is just what you were doing before with your first rung. You're on the first rung. Maybe it's like the height of you. So you're on the first rung, and then somehow you have the abdominal or arm strength to pull yourself up to the second one. So you just keep doing that, right? So on the first one you got to the second. From the second you got to the third. So now what we're saying is we're just generalizing it. So you pick any k. So here we're working with the natural numbers, if you haven't noticed already. We start at 1 and it goes forever, and they're just integers, right? You're not going to have 1/2 of a rung or something. At least not in this ladder. This is a sturdy ladder. So you get helicoptered in on the kth one. If you can show me from the kth one, you're already on it, you're there, that you can get to the k plus first rung, well, now I can believe it, right? What else can you show me? You could show me you can get to the ladder, and if you're on the kth rung, you can get to the k plus first rung. So we could do that for all of them, right? We could start at 1 so you can get to 1, right? And then so let 1 be k, so you can get to 2, right? So k plus 1. And then the second rung, you can let that be k. So we're at 2. We want to get to 2 plus 1, which is 3. Do you see what I'm saying? So if I'm like, well, does this work for, let's say, 4? You could say, well, it worked for, I'm able to get to 1. And so then it will work for 2. So since it works for 2, it'll work for 3. And since it works for 3, it'll work for 4. Do you see how I'm just looping? So you start with your initial, I can get to the ladder, and then you're just looping this k plus 1 thing until you get to whatever number that you want it to be. Okay, so I was asking you, can you even get to the 4th rung? And so you showed me, yes, I can. Okay, if I said the 1000th rung, it'd be the same thing. But the beauty of it is, because we call this induction and it's like a well-known argument that it's true and things like that, you don't have to make that whole argument of like, oh, well, you pick 1001, well, I'll show you, like, so we started 1, we do 2, we do 3, we don't have to do that. But if you do what I said before of showing you can get to the ladder, get to the 1st rung, and then if you're on the kth rung, that you can get to the k plus 1st, you're already done. You already made all those arguments. Okay, now the reader, if they're like, wait, I really don't believe that you can get to the 2004th rung, then you could just tell them, well, read my argument, and you can just keep rolling through it. Okay. This is what's hard about this online teaching is I can't read the room. I'm the only one in the room, me and my 2 rabbits. So I hope that this is making sense so far. If it is not, that is okay. Okay, sometimes it takes people a while to get this stuff. You can start over again, or you can keep powering through this video and see if it starts making sense later. I know for me, I'm actually watching a mini course right now, this week and next. And when she first presents the material to me, it's very difficult for me to follow. I mean, she's a great presenter, but it's difficult for me to follow. I'm not really understanding what's going on. But then I go back, because thankfully they record it. I go back and I watch it a second time, and now I'm picking up on more stuff. And then I watch it a third time, and now I'm really starting to get the nuances that she was speaking of. Okay, so math is a process. Okay. All right. Okay, so step 1 is, can I get to the 1st rung? Okay. Step 2 is assume I'm on the kth rung. Okay. And then step 3, can I get to the k plus 1st rung? So that's it, bippity boppity boo. Once you show this, you show that you could climb an infinite ladder. Okay? Given all those caveats. All right. So now let me give you a sketch, and let me emphasize sketch of how you would do a induction proof, like with math terms. So if you remember, P parenthesis N means it's a conditional statement. So whether the statement is true or false depends on what N is. Okay, so remember before I said, I used the example P parenthesis N, and parenthesis was like N is odd. So P parenthesis 3 is true, but then P parenthesis 2 is false. Okay, so here's just an example. It doesn't always have to be the natural numbers, but we'll talk about that later. Right now, we're just going to live in the naturals world, and we want to show that for any natural number, P, the conditional statement P, depending on N, is true. Okay, that's what I want to show. So I'm going to do proof by induction. So what I call step 1 is I call it base case. Now, you're not going to lose points if you don't label your cases, but I definitely like to do it so that I remember what order I'm supposed to be doing things in, and I remember what I'm supposed to do in each part, and it makes it easier for the grader to read. So I call the first one base case. So we're going to let n equal 1. Now, here's what trips up a lot of people. A lot of people, if they're trying to show two things are equal, maybe, they'll just write them as equal. But no, you just want to explore what it means when n equals 1, and then eventually show or demonstrate that P parenthesis 1 is true. Okay, you can't start by assuming that. So you'll do some work, more work maybe, and then you say, therefore P sub 1 is true. Okay, so check. Step 1 done. I can get on the ladder. So my next one, I sometimes call it inductive hypothesis. So my inductive hypothesis is I'm going to assume PK is true. P of K true for some K in the naturals. Okay? Because like I don't want to choose K as 1/2 or something. I don't even care if P of P parentheses 1/2 is true or not. Okay? It doesn't have to do anything with what I'm trying to show. So here, this is where the helicopter brings you in onto the kth rung. Okay, so now we have to show you can get to the k plus first rung. So this is the inductive step. At least that's what I call it. I'm sure other people have many different ways of calling these things. Oop, just one step. Okay. So now I love talking about what it is that I want. That really helps me on inductive steps. So what do I want? Well, I want P K plus 1. Inductive step. So now how I typically start inductive steps is I ask my reader to consider something. All right, because oftentimes you have like you want two things to be equal. So you could start with one side or the other side, and then you can show that it also equals the other things. Like let's say you start with the left-hand side and you go through all of these computations and then you show that it's also equal to the right-hand side. So I'm just going to sketch out something that looks like that, but it won't always be that way. Consider, If you do not use your inductive hypothesis, alarm bells should be going off in your head that somewhere something is wrong. Or maybe you did use it and you didn't realize it. But either way, reread what you wrote, okay? You have to use your inductive hypothesis, okay? So use PK, and then so you do a bunch of work, you say a bunch of true things. PK plus 1 is true. Okay, so remember you always need a conclusion. So your conclusion, all you have to say is, therefore. So all you have to say is therefore Pn true for all n in the naturals by induction. So you do want to use the word induction somewhere in your conclusion. So if you're looking at this and you're like, well, Danica, I still don't super understand how this is proving it for all n. I would suggest to watch the beginning of this video again. Sometimes for people, it's better if I show them this and then they listen to the weird explanation of the ladder. Sometimes it's the other way around. Whatever works for you, run with it. Okay, let me make a note about our indexing. So here we indexed over the naturals, but that's not always the case. So one simple example is maybe we would use n union 0. Okay, so maybe the question just involves 0 as well as the natural numbers. What always trips people up, or what often trips people up, is the integers. So the naturals, what's nice about the naturals is you only get bigger, right? So you start with your base case as 1 and you just get bigger. Or if you do this union thing, you start with your base case as 0. Oh, that's another thing I should say. So your base case is just the start of your ladder. Okay, so what if we wanted to climb a ladder that looked like the integers? Well, you might think, let's have our base case be 0. But the problem with that is now we have it's going up and it's going down. Okay, so there's a lot to show here, and how I will suggest that you approach this is that you split this into 3 cases. So that might sound like a lot, but one of them is pretty simple. So I suggest that you split this up into the 0th case. So just consider 0. The natural numbers, and then like the negative naturals. So how about I'll write, okay. So now, 0 is kind of like almost like a jump rope or something. It's not really a ladder. But this one is the ladder that we know and love. And then this one is as well. But our base case would be -1. So here's, let me at least set this up for you. So base case would be n equals -1. And then our inductive hypothesis, we would assume PK true. Okay. Or you could even call it like -k and be pulling the k's out of the natural numbers. I recognize that this is a lot. Okay. So PK true, and then your inductive step, you want, so this is a rough sketch, just so everyone knows. You want to show PK -1 true. Okay? Because here we're presenting K, so K is from this set. So it's a negative integer. So if K is a negative integer, then K -1. So, or you could think about it as maybe you're going into an abyss. So you're going down the ladder. Or you flip it upside down and you just call them negatives and you're going up the ladder. Okay. So this is not something that necessarily would be tested on. It's just my previous times teaching this, I've always had students ask me about this. So now I'm finally remembering to address it in class while I'm teaching induction. Okay. All right. So I hope that this helps. If you're confused, feel free to go on to the next one where I talk about an example, or rewatch this, or reach out to your instructor, reach out to me, anything. Okay. Good luck.